This video has been sponsored by Nuage Networks. For more information on the Nuage Virtualized Services platform and how Nuage is delivering consistent policy-driven automation across data centers, the WAN, and branch locations everywhere, please visit nuagenetworks.net and follow us on Twitter at Nuage Networks. We hope you enjoy the session.
After watching this video, visit ipspace.net/sdn to learn more about software-defined networking and overlay virtual networks. Let me briefly run through what the service chaining is and what the use cases may be. You may want to insert some physical appliance like a firewall between virtual machines, or you may want to insert some network services or security within a subnet, or you may want to create multi-tier applications, but you don't want to split them in subnets, you don't want to have the routing overhead, or particularly in NFV environments, network function virtualization environments, you might want to combine multiple services into a single user experience. You may insert transparent or routed services in the forwarding path. Transparent services are like bump in the wire. The only problem is that this bump in the wire is now not sitting on the wire, but is removed from the wire. So we need to do some special tricks. Let's say to make our lives even more complex, that we don't want to have services between A and S. So from A to S, we go direct. But from B to S, we will send the packets to the firewall in this case, which then sends the packet to S. If you want to make your life even more complex, you would say, well, I only want to do this for port 80, but not for port 443. And then in the return direction, obviously, you have to do the same thing. So as the packets go back, some packets go straight and some packets have to go through the firewalls. Typically, you would do this with something like VLAN chaining, but that doesn't work for individual endpoints. It's impossible to do for individual applications. And in any way, VLAN chaining has fantastic potential for forwarding loops. Layer 3 service insertion is way better because we just need to redirect packets and we rewrite MAC addresses, and it's way simpler. So A talks to the server, but the destination MAC address is actually the MAC address of the gateway, which is over here. This is sent forward, and here the MAC header says it goes from the gateway to the server. So this is the traditional routing. On the other hand, as B is sending a packet to the server, the packet is rewritten, the header is rewritten and is sent now to the MAC address of the firewall. And then it's sent from the firewall on the other end in the other subnet and to the server. Likewise, as the packets go back, this goes direct and these packets go through the firewall. This is way simpler to implement, and usually we would use something like a policy-based routing, in which case MAC rewrite is automatic. But in traditional networking world, this is hard to implement if you have something in between here. So if you have firewall attached with a layer 2 segment to this router, it's easily done, well, apart from distributing the PBR policies. But if you have a layer 3 or multiple layer 3 segments between the two, then things get interesting. So let's see how Nuage solved this. First, you have to define the rules in something called VSD architect. These are actually the redirection rules. So it's effectively PBR. And these rules are downloaded on demand to VSC and then instantiated as OpenFlow entries on the VM port. So when a VM is activated, we already went through this, VSC is informed, it asks VSD what to do, it gets the definition of the policy, including the service chaining rules, and it installs the corresponding OpenFlow entries into the VRS. From the scalability perspective, the traffic redirection uses the same mechanisms as security groups. So you can define groups and then you say, well, traffic going between this group and this other group has to go through the firewall. If you have large-scale implementations, they are using additional tricks with multiple forwarding domains that I'll not go into here. If you want to know more about that, send Dimitri an email and he'll give you more information. On the control and data plane, the appliances are identified by so-called virtual port tags, and the appliances can be physical or virtual. Obviously, physical appliances would be attached to some sort of a hardware gateway. And then the VSC would create a dedicated VXLAN segment for every appliance port. So this would be an independent segment, and this would be an independent segment. Then the information about the appliance and the transport next hop and the segment is propagated in EVPN update like in any other case. And now we have a regular EVPN update, fully qualified with transport next hop, VNI, and so on. And we can use now this information as the PBR next hop, which means that in here we just install the information saying, well, if this and this and this and this matches, send this packet to that particular next hop. If this would be a virtual appliance and you move it to a different hypervisor, the EVPN update would change and the next hops here would be automatically updated. And now for the final complication, what if we want to have two appliances for resiliency? In that case, yet again, each port gets its own VNI segment, here and here, because we need that for proper next hop indication. And then VSP creates a layer 2 VPN between these two and between these two, because the appliances need that for keep alive mechanisms. Then the two appliances start doing whatever they do, and one of them decides that it's active. The usual way to indicate that an appliance is active is by sending a gratuitous ARP with the shared IP address of the appliance and a MAC address of the appliance that is currently active. When the VSC receives that, it creates a host route pointing to this appliance. This host route is leaked. It can be even sent across different VSCs in multi-protocol BGP update. And yet again, we can now use this IP address, this host route, as the PBR next hop. When this appliance goes down and this appliance sends a gratuitous ARP, the host route information is changed, is propagated through BGP across the different availability zones, and all the entries in the affected VRSs are corrected to the new next hop so that this VM continues sending the packet through the now active appliance. If you like this video, go to ipspace.net/cloud to explore other overlay virtual networking webinars.